This is an overview of the cloud network defense from Wedge networks. Cloud network defense is a security services platform that enables security for the cloud-connected world. According to Cloud Ethernet Forum, 70% of the new Ethernet ports that will be installed in the next 3 years worldwide will be in the cloud service provider networks. We are living in a new world, and this new world is a cloud-connected world. And this new connectivity have introduced a new set of security issues that we need to address. To address these issues, let's do a review of how we come up with today's security protections. This diagram shows a very simple connectivity scheme where a bulky computer is connected to the local network, and the local network is connected to the internet. In fact, this is the connectivity that we have been living with for the last 30 years. There were a lot of security breaches happened in this kind of connectivity. To manage this security and prevent these threats from the internet, organizations first install something called a firewall that prevents Trojans and worms that come into the network, where they later on find it's not enough. They find out the firewall is not sufficient. Then we started installing security software on computing devices. Now, this has been working pretty much well for a little while. However, in the last several years, things have changed. There emerged the cloud. And gradually, there are a lot of new, very cool applications that are being populated in this cloud that attracts many, many businesses. In fact, discount all the large businesses worldwide, currently there are 220 million small to medium businesses connect to this cloud with these cool apps. What's more, there are 2.1 billion mobile computing devices also start connecting to this cloud, start using Facebook, and start sharing files through Dropbox. And what's more is that now there are more than 18 billion Internet of Things devices, those smart grids, your smart appliances, also start connecting to the cloud. And you can see that all these new connectivities really do not use the old security paradigm. So what happened about security? I want to point out again, this is really the change of the paradigm, right? From the old connectivity and old security to the new connectivity. Now we start asking what happened to the security. One thing to note, all of today's security measures are implemented for the last 30 years, the old connectivity. As a result, all the mainstream security solutions cannot adequately handle today's threats. And this diagram is from, for the last several years, you can see that the security breaches actually grows exponentially, and especially the malicious attacks and hacking grows exponentially. That's why you see all these very high-profile breach incidents, Sony film breaches, and healthcare data breaches, all those things, right? And what we really need is a new breed of security that can handle today's cloud-connected world, security for the cloud-connected world. To start, let's work from scratch. This is the very basic connectivity of today, right? You got a lot of businesses, you got a lot of mobile users, you also got a lot of Internet of Things devices that are connected to the internet, which has a lot of cool applications that serving these computing devices. What we would like to do is to somehow inject the very sophisticated advanced security functions in this mist so that the computing devices can be protected against data theft, against malicious attacks. How do we do so? As you know, that network has been evolving very complex, right? It's very difficult to inject anything into a network. It's very costly. Unfortunately, there is a major movement in the industry which is called software-defined networking, SDN in short. With software-defined networking, the network is being reshaped by separating the very complex control functions away from the network connectivity. As you can see here, now we got data plane and the control plane. Okay? And the security can definitely be installed in the control plane. And in this diagram here, we see that, look, we have introduced some kind of systems which we call terminals. These terminals allow you to basically change the data flow based on some policies, and then we can actually do security services for this data flow. In order to coordinate this forwarding of network traffic with the security functions that applies to this network traffic, we have implemented a system called a service conductor that allows the network security to be applied to network traffic to achieve security goals. What is important is that different organizations, individuals, has different security requirements. These requirements are being defined as security policies. So the service conductor actually gets its instruction from another layer, which is called security policies. And in a typical organization, being a service provider or enterprise, these security policies are typically being defined by some kind of graphical user interface, such as a web portal. With this, as you can see, that policy being defined and then being coordinated by the service conductor, and then it drives the terminals to forward net traffic for security purposes. Then we can block attacks, identify security breach incidents, and we can actually generate reports and analytics for future planning. And this is the reports and analytics part. Okay. Now, almost like we have solved the problem. But as you know, one thing in the internet age is that things always change. And as we find out, suddenly there are more and more computing devices connected to the network. Now, what's the impact for this? Okay. We know that security operations are very computationally expensive. When we have more devices to be served by security, what will happen is that the security functions can become a bottleneck. And if you don't resolve this issue, you have unreliable networks, you are going to have slow networks. So to solve this problem, we come up with another subsystem, which is called cloud conductor. The goal of the cloud conductor is actually calculate the network stress, the computational stress of the security functions, and try to spawn off new instances of security systems. And here is what happens. When the network traffic goes up, when there is a lot of computing devices, and the new security instances are being spun off, hence the service level are being maintained. To put all the systems in a software, and we come up with a software package, which is Cloud Network Defense, right? When you install this Cloud Network Defense into your common hardware platforms in a typical data center that is operated either by an enterprise, by a public cloud service providers, or by internet service providers, you see this whole thing in production, right? In fact, Cloud Networks is the highest performance cloud security platform in the world. It provides security protection for this new cloud-connected world. Cloud Network Defense is a patented platform. It is award-winning. It is installed in several thousands networks worldwide, providing security protection for 20 million computing devices.